You.
Thanks, Kani, and thanks to Code Chrysalis for having me. Hello, everyone. It's not working. Un momento. Where did the presentation go?
It's probably on the other screen. It's extended.
And here it is. All right, how's it going, everyone? So I can see like a manageable amount of people today, so we can have it low key. Feel free to ask questions, and sometimes maybe interrupt me if you don't understand anything. And today I'm going to talk about scaling. My name is Michael Makarov. I work for Salesforce right now. Before I was founding engineer of a startup. And before that, I worked for a consultancy, and we helped other companies scaling or build their products, prototype their products as well. And let's just start. Okay, so what is scaling? Scaling is very common for any startup or any company. When they start with a very simple product, right? And then their user base grows, their features grow, and the app gets more complex. They run into so-called scaling issues. It's like in San Francisco, right? You have a lot of friends, and sometimes you call them and ask, "Hey, how's it going?" And they're like, "We have scaling issues." That's basically the emotion that is associated with scaling issues. So it's very common, and probably if you found a startup, or if you work on something small that's going to grow, at some point you will face them. And in this presentation, I want to share my experience how to tackle scaling issues. And what is scaling? Scaling is just tackling scaling issues, maintaining the app functionality. Make sure the app doesn't crash, right? Next slide. Yeah, and I'm going to talk about how to deal with scaling issues in this presentation. This is a little plan of what we're going to go through. And first, we're going to start with the most important, in my opinion, thing called measuring your app. Basically, measuring its performance, right? The next is how to optimize things. I'm going to cover cache a little bit, Async, Microservices. It's actually back to, I'm sorry, I don't remember your name. Sebastian?
Yes.
Yes, so it may actually be helpful for you, for your question. And then we'll talk about buy versus build, your favorite topic, tests, and then upgrade strategy, auto-scaling, team growth, and then code debt. So any non-engineers in this audience? 1, 2, 3. Just imagine that you're engineers, so we can understand better. But feel free sometimes to just ask questions. And let's start. Sorry, it's the wrong slide. Let's start. Measuring. So basically, measuring is a vital part of building an app, right? Without measuring, if you don't measure your performance and your app, it's like you run with your eyes closed, right? So you can pretty much run into a Telegraph post or into a crowd of really angry engineers. And you have to constantly monitor like how your app is doing. And then, because that will show you potential bottlenecks, and then that's how you know like what you have to optimize before your clients tell you about that. Because sometimes you get like a message or a call from a customer and they say, "Hey, it's really slow. We try to like do this thing, but it just doesn't work. It takes like so much time, and then it times out, right? When the request takes more than 15 seconds, for example, it times out, right? So you don't want your customers telling you that. You want to see that in advance yourself. So you want to measure your performance. And when you measure things, you want to see different metrics, such as request counts, to see like which requests in your app are the most used. For example, if you have an API, like selling API, maybe the most common request is checking the price, right? And that means that maybe you can, if it's called so many times, and it accesses the database, maybe you can optimize it and cache it, for example. You can see longest API calls, for example, which API calls are the longest calls, right? And you can also optimize it. In this case, maybe the query, the database query is long, or maybe you also can cache it. So you can find bottlenecks. And the good news is you don't have to build it yourself. You can, but you don't have to, because there's already a lot of tools that do that, such as New Relic, Datadog, Airbrake, and there's a bunch of other tools. One of the most used tools for me was New Relic. They are IPO'd, so it's a public company, and they support all sort of languages, and they're very easy to use. They're a little pricey, but compared to building your own, they're very cheap. Let's go to the next slide, and in the next slide, I have a screenshot that I took from Google Pictures of an example of what information New Relic gives you, right? So here you will see how different layers of your app perform, right? This blue thing is Ruby. An example is Ruby on Rails, right? So Ruby actually takes a lot of resources to perform, right? And compared to Ruby, database is like a smaller line, right? So you want to kind of look into this, into graphs like that and see if there's any like strange anomalies. On this graph, for example, sometimes this database can like go really high, really big, and you know, maybe we need to, this is the bottleneck, we need to optimize the database. For example, in this case, the Ruby is big. I don't think it's a problem in this case because the average is 204 milliseconds, right, the image request time. But if it was like, let's say 700 milliseconds, maybe a right way to tackle it would be to rewrite something not in Ruby, or maybe to revisit like how it's being implemented when there's some implementation issues. So here we see web transactions, right? They are sorted by the average server time, and as we see, alerts events controller is the longest one. It takes 860 milliseconds, which is slow, right? I think everything below 200 or roughly 200 milliseconds, I would consider sort of very slow. That's also a red flag. You can sort things by how fast they are, and if you want to optimize things, you can optimize from the top, right? You see, this is so slow. You got to do something about it, right? And this is just this is RPM, like request per second, and you can get all sorts of information. There's so many graphs, like request per seconds per API call, right? You can see which ones have the most RPMs, and you can optimize the ones that have the most RPMs. Request per seconds basically is how many times per minute, right? How many times per minute this API route is being called. For example, if I go on Google, and if I was the only customer that Google has, right? Everybody else would go somewhere like, for example, watch Bachelors, right? For some reason, right? And I was the only Google, and I go to Google, click search, and then I click search again, and click search again. If I click 3 times in a minute, then the RPM for Google will be 3, right? What it's called. You have any questions so far? Yes, please.
So this graph that's, the colorful graph that's being displayed. So this is on all instances. I'm just having trouble understanding what specific metric this is being.
That's a very good question. So it's a very, you can customize it for your specific app. You can customize it by instances, or it can basically use all your instances, right? So it can just intercept any call, regardless of which instance it lives on. But you can also like have like separate metrics for different instances, for example. So it's very flexible for New Relic and for other tools as well. Yes, please.
We use Datadog. I have never touched New Relic. Is it equally complex or difficult to set up?
Yeah.
Probes, I mean, how do you set it up?
Good question. So Datadog is probably. Are you a product by any chance?
Sorry?
Are you a product manager by any chance?
Well, yes. I mean, yes.
Got it. So New Relic is more specific to like the backend, to the code, and Datadog is, and also it gives you graphs just for scaling things, right? Datadog is where you configure which data you want to send, And it's probably used a little more for like a product management, right? So you know what your users do on the web page, like what are the popular places they go to, like how many times they execute like different features, which is also a good metrics for scaling, of course, but it's just a little different. It's more like I would say, in my experience, it was more user interacting level as opposed to like this sort of more like back-end kind of analytics, like your app analytics. Yeah. Yeah, so you, it's just to conclude, you basically have to watch the metrics each time, because otherwise you'll be a doctor that cannot run the lab tests on the patient. But with this, you will know, with metrics, you will know like what exactly the problem is. And the next slide. So basically, if I simplify the whole process of optimization, it's measure, optimize, measure, optimize, measure, optimize, right? So you measure your app and then you optimize it. Very simple, right? Sounds very simple. And here I list maybe 80% of tools that I use to optimize things, right? My favorite sort of go-tos. And one of the most important things that I do is caching, right? There's going to be a separate slide about caching, but if you have a query that takes such a long time, you can cache it, right? So we're going to talk about caching a little more, and I'll tell you what it is. Then one other optimization is there's a lot of cases when a database query is not just written well, right? So for example, it queries something, but the indexing doesn't work properly, so you can optimize the database. Maybe the code is, you have to revisit the code, it's not very efficient, right? It uses some loops that not very like memory friendly. And one of the things might be switch technology. If you used something like Visual Basic or some like really slow language, whatever it is, maybe there's like for your purpose, maybe there's a faster language, like for example C, or you can implement a new technology such as Elasticsearch, right? If you have search on your page instead of just using the database each time, or you can move something to an async job that we're going to talk about. So in case if you don't know what async job is, or in case you don't know what cache is, we're going to talk about it later. So I'm going to go to the next slide. And I think we have a scaling issue. So it's not the battery here. You know what? It could be. Is it out of focus? Yes, it may have gone. It may have gone out of focus. Let's see. All right. So let's switch. Oh, no, maybe it is some sort of out of focus. Just give me a second. Meanwhile, come up with some complicated questions.
Are you going to talk about like parallelizing or?
Sure. Yes.
Okay.
Yes. A good question. Okay. The slides are back. So forget all the complicated questions right now. First slide is caching. Caching is if you have a result of very expensive computation, such as a hardcore query or some sort of big computation, such as results of AI or like image processing, right? Or such as just like big database request. You can save that and just serve it as it is, as a saved thing as opposed to run this query again, right? So, when something doesn't change much but being read often, right? For example, I have a very good example that I think is a very good example. You guys know Facebook? Who doesn't know Facebook? Who deleted their Facebook? Anybody deleted Facebook? Not yet? Okay, fine. So in Facebook, you know how you scroll the feed and it's really fast. Or like scroll the feed on your profile, it's really fast. But as you go really far down, it gets slower and slower and slower. And then at one point it gets so slow, you like imagine that you probably think it's like, you like running, basically it gets so slow. And in the Messenger, right, you have threads. And all the fresh threads are really fast. But if you find someone who, like, you messaged like 3 years ago, right? You open the thread, it will take really long time for messages to load. The reason is because they cache all the fresh threads, and they're really fast. But then the old threads that are not yet cached, they are really slow, right? And then once you open them, they become cached, and then it can serve fast. So they don't have to do this database query each time. But cache is considered way faster, but like more expensive, right? Normally, it also depends on the cache you use, right? When you architect, cache is also considered not reliable, although it is reliable. But think about it is that if your cache get flashed for some point, right, the app has to recache it, and you never have to. You should never like use cache as the source of truth, and because it's also expensive, it usually has an expiration. So, for example, you cache things only for like 2 days, and for example, if you don't open this thread, you messaging with your friend more than 2 days. That means you probably don't want to open it anymore, and you don't have to like keep it in the memory, right? So it will uncache. Even Facebook will uncache some threads at some point. So it's very useful to cache things that are like being accessed for a long time, for a lot of time, right? So you don't have to hit the database each time. There's a lot of way of caching. For example, WordPress, they just cache the whole file, right? A lot of news companies, right? They cache the whole front page, right? So they don't go and query the different news on the front page each time you open it, because they add news not very often, like 10 times a day, like 20 times a day. So each time they add something, they recache the front page, and then the page is cached. So each time there's a lot of users come to the news, open the page, and it's already like loaded. This is like evil red color scheme right now because of my flux. But yeah, let's make it a little more friendlier. Okay, disable it for 1 hour. Now it's back. As well as there's maybe you heard about Redis. So Redis is more like when you save key value, right? So it's basically like JavaScript objects, right? But it has also a lot of tools with it. It has like queues, and now they have so many features. It's very, very convenient. I like Redis. If you don't know yet what Redis is, Google it. Then you have any questions about caching?
Why do you call it expensive? In what sense?
That's a very good question. That's a very good question. So, for example, saving files on disk is not very expensive at all. But, for example, keeping queries in Redis is more expensive. Redis is more expensive. If you go and check the pricing, it's way cheaper to get like a hardcore database, like really powerful RDS database, right, for Amazon, as opposed to like get like even one like gig of Redis. But yeah, it's a very good question. So I see a lot of people use Redis. That's why I said it's expensive. But there's a lot of ways of caching that are not very expensive. as well. Yeah. Any other questions? No questions? You don't have any questions? Nice. I like you guys, you don't have many questions. That means you understand everything I say. Okay, the next slide is async, queues and jobs. Maybe it is actually, it's about the thing you ask when you split things. So for example, you know how, let's say in a coffee shop, right? If 50 people come to a coffee shop at the same time, you can't serve them coffee at the same time because coffee machine has limited amount of valves, and then you have to have a line so people come one by one. Otherwise, your bartender are going to explode. The same with applications, right? If you have a lot of requests, like heavy query requests, if your users come to your web page and open that heavy page at the same time, your app may probably crash, right? So in this case, you make a queue, and then you queue the jobs, and then they run one by one. And also very handy because those jobs can run on a completely different machine, or you can have one machine per job, and you can configure it in all very flexible ways, so your app can scale really well. So if it's, for example, a very common task for jobs is some sort of computerization, image document processing, right? AI, right? If you can just analyze data sets with AI real time. You can, but in a lot of cases you can. There's a lot of data. So you probably want to create a new instance or run that process on a different machine. And if you do a series of external API calls, right? You don't want to do it inline when somebody makes a request, because as you know, a usual configuration for any HTTP request is to give a timeout in 15 seconds, right? So let's say if you have an API request and it's been open for 15 seconds, then it will return a timeout, right? So you can always configure it to be 25 seconds, 30 seconds, but it's not a very good way to do, to tackle it. In this case, you can return a green light. It says your query has been received, and then do it in the background. And then once the process was completed, you can update whoever requested it to saying that your task was completed. And for all complicated tasks, it's better to put them into the jobs and queue them. So your app stays functional while other jobs complete the heavy task in the background, basically. And there's a lot of queues now on the market that you can easily use, and you don't have to build it yourself. There's RabbitMQ that I really like. It's very simple. Kafka, Sidekick, Amazon SQS, and also the queues are very handy because it helps you to build. It may help you to build architecture, microservice-oriented architecture, service-oriented architecture, right? Because you can have different apps can communicate with the queue between each other. So once one job is completed, the other program can take over and do some other processing on it. Do you guys have any questions about this? No? No questions. Wow, awesome. That's very, very productive. The next is microservices. Have you heard of microservices before? No? Anybody heard? Raise your hands. Cool, awesome. Who wants to explain what it is? Oh, yes, please.
I want to ask the explanation about microservices.
Oh, okay. Who can explain what it is?
It's breaking down a monolithic application in smaller chunks.
Nice.
That are more manageable.
Very precisely. So as your app grows, right, it's getting bigger and bigger. And it's very common to split this app, to monolith app, to multiple applications, so it's easier to maintain, right? Because empirically, right, a lot of companies who have monolith apps, they are suffering, and they always we got this monolith app, you gotta split it out, split it up. And if you split the app, right, to multiple sub-apps, it's easier to maintain. You can write tests for each of the sub-app. It's the different Steam. You have less code within each app, so you can also replace different parts. It's also very important for scaling in terms of maybe team growth as well. Yeah, and it's easier to write unit tests, right? Because you can test different specifics of like a part of your app. Although integration testing gets a little more trickier. You have to mock some data and stuff like that. So it's also a very big buzzword, right? Service-oriented, microservices. Yeah, and sort of like Lego over here, like a picture of Lego. You connect the pieces and just magically works. You have any questions about this? Yes, please.
What's your experience with like taking, for example, one monolithic app and splitting it up into, I don't know, there's this Node.js microservice buzz thing going on for the last couple of years, and I've read some pretty nasty stories about people that had, like, say, an old Java app running JVM, and they had all the stats, and then they chop it up into little Node.js processes, which is very cool and easy to manage, but then they end up having huge trouble to kind of like scale that or actually manage the resource usage for all those tiny little processes in Node.js. What's your experience?
Oh, yeah, got it.
Maybe not necessarily Node, but I just want to hear how you.
Yeah, got it. It's a very good question. When you split your app, it always like adds a little bit of complexity because the maintaining can be a little harder in a way that if your, for example, team is small and your app is not very big, there is no point to like just split it right away because you'll have multiple repos, and it may actually add work to maintain those repos. So you have to like think what benefits you can sort of gain, and if your team is really big, then it makes sense to split. But if it's still small, then probably splitting it may add more work. And of course, if you just start splitting it, it's you may want to like add a lot of tests and stuff. It may go complex. It may become more complex, but I guess you should apply common sense when you split the apps. And it's also, of course, case specific. I'm not sure, like, but I can see people like splitting apps and they go through a lot of hell. So they split up and they came back into like spaghetti. We have old legacy Java application and then new spaghetti, like of different Node apps. So I guess it depends. But what we did, we split, for example, for different purposes. We used different repo. We had like, for example, a Ruby app, and we created a separate Node.js service that would run some specific task. And it worked really great. It had its own tests, and it would live in on its own server. And that was very successful, and it was really fast and interesting. Yeah. You have any more questions? Hopefully it was useful answer.
I could ask more nasty questions about back pressure and stuff, but I'm not going to do that.
You don't do that? Okay, yeah, you can do that. You're the only person who asks questions. So. Nice, thanks. Okay, buy versus build. You probably know about this problem, and it's applicable even for big companies acquiring smaller companies or building their own product, and it's applicable if you want to, for example, use AWS as opposed to Heroku, right? How do you choose? So a few things that I use is when it's cheaper to buy something than paying to the engineers who are going to build it, it's better to buy. Such as, for example, if your app is small and you can pay Heroku less than say $8,000 a month, then it's better to have Heroku. But when the price of Heroku grows, so you can hire an engineer and actually save money on it, it's better to hire an engineer and save money. Then the other approach that I use, that might not actually be it's not maybe true for everyone, is if something is not part of your core business, like for example, if you're a company that sells tires, like for cars, you don't want to invent your own like document embedded system for editing documents, right? But so it's better for you to concentrate on your main business and then just reuse some apps that can help you scale, right? But that is not very applicable to some companies, because some companies are being acquired if a bigger company wants to scale their revenue, or if a bigger company wants to come into a new market, right? So in this case, they still buy smaller startups. And also one of the very common cases is acqui-hire, when a company is being acquired just because the bigger company needs technology, or the engineers. They just want to hire the engineers, and engineers are very hard to hire, right? But that problem will be solved when Chrysalis will release more engineers, so you don't have to actually acqui-hire, you just can hire engineers from Chrysalis. And yeah, for example, email service, right? You don't have to create your own email service, you can just use it as a service. It's cheaper and it's more pleasant. The next is your favorite part. If you scale, tests are vital. It's very important, because if your code grows, it's hard to find like who was responsible to which part, and then you go and you add a feature and you break all other features. And if you don't test, you won't even know. You say like, oh yes, my feature works fine. I don't know why the app is not working, right? So that's why it's important to have tests and test as much as possible. Every mature company tests like everything, right? Mostly unit tests because they're faster, but also integration tests. Also, everybody uses CI, right? When you use GitHub and you commit the code and you want to push a pull request, usually the test run on CI to make sure that your code didn't break any existing code. Not only that, in companies that I worked before, right, and I work, they have threshold, right, test threshold. And if you release a feature and then the amount of tests, there are different metrics how you can measure your tests, right? But let's say you can just measure it in percentage, right? So if the code coverage is less than 70%, it won't let you merge your pull requests, right? And that's actually very good for the new engineers, so they develop a habit of writing tests. And maybe also you can apply TDD. Right now, I don't see a lot of companies that apply TDD per se, but people sort of write tests as they write code. Not like starting with tests, but at the same time. But TDD was also, when I started, I did a lot of TDD. It was a very good exercise to develop my sort of instinct of writing tests. And no tests, it always takes, it's more expensive to develop things, because you'll get so many bugs, and then you'll spend all your time just figuring out what broke, right? But if you have tests, you can run them and immediately see what exactly broke. Basically, in case any of you don't know what like tests are, it's basically a robot. You build a robot, and then you tell the robot what to do, and it goes through your app, like clicks around, and run different functions, and make sure they work properly. And if something doesn't work, it will report you, it doesn't work here, or it doesn't work there, and it will take you a specific place where it doesn't work, and specific case why it doesn't work. So you can easily tell, I know exactly why it happened, because Mr. Tanaka committed code like 2 minutes ago that probably broke it. Upgrade strategy. What do you think upgrade strategy is? Any guesses? Nice, exactly. So they always release new versions of libraries, right? They always release, what's the most important is security patches, right? Whatever framework you use, they always like find some new vulnerabilities. And as a company, you have a lot of liability. You have users' data. You don't want some other companies to steal your data. Like if it's Cambridge Analytica or some other company, you want to make sure that they don't exploit, basically don't use these vulnerabilities in software and steal user data. So, and to do that, you want to upgrade the latest versions of GEMS, specifically the vulnerability, like security patches, and you want to keep track on them to make sure your application is very secure. But also, they always optimize their software as well. Because in now building as an application, while you build an application, anyone who builds application really uses a lot of libraries. Now you can't just build everything from scratch. Nobody does that unless you, it will take you forever to build anything from scratch. So you want to make sure to update the latest versions of software libraries, right? But there's also a catch that if, for example, they release the newest version of some framework, you don't want to immediately update it unless it's a security patch, because it might introduce new bugs for your software and your software might break. You want to wait a little bit to make sure that they fixed all new issues introduced with new features of the framework that, that was released. But then if you don't update for a long time, it takes harder to update, especially all these frameworks. If you skip one version and they release a new version and then they release a new version, it will just take a long time to upgrade one by one and fix your app. So you want to keep track on that, and you definitely want to come up with some upgrade strategy, like revisit upgrades every like 3 months, for example, right? Unless it's security updates that you have to sort of update immediately, right? Any questions? You're my best audience. I want to come and talk again about anything. Okay, autoscaling. Anybody can guess what autoscaling is? I know you can guess what autoscaling is. What's autoscaling?
So, if my app is not using much resources, I want to get rid of the compute instances and stuff.
Nice. So, perfect. So, the workload is not usually evenly distributed throughout the day, right? And sometimes you have a lot of users during the day, but at night users are sleeping. And if you have like, if you use like large resources to run your application, you can scale it down at night, knowing that there's not going to be a lot of users. And you can use a robot to see if there's a lot of users, then to basically scale them up. And if there's like not that many users, like scale them down, because it can save you money. Yeah, unless you just waste so much money that you don't care, which is amazing. I assume there was no question. Okay, team growth. Yeah, I just put this really cute GIF to entertain you a little bit. I'll just make sure until everyone laughs a little bit. Continue. All right, so your team is going to grow, and that's when sometimes I've seen that cases where people would just like push right into the code, right? Just pull it, do a change and push. When your team grows, you can do that. You have to go through code reviews, you have to go through pull requests, and you have to run tests on CI. That's from a software engineering perspective. That's the thing for me about team growth to to accomplish that when you scale your app. The code reviews help beginners to kind of grow their skills, because some more experienced engineers can tell them, aha, you can use some other algorithm here, or you can like improve it here and there. Also, it helps keep team updated. So all teams synced about the knowledge, what's going on, so you can see how things work. So at least you like have an understanding like how features are being done. And also, of course, you can like oversee some bugs. Maybe some person just had a typo, and that's very common in any companies. People do typos very strangely, and or if you're just passive aggressive, you can just write angry comments in some code. I'm just kidding. Sorry. Yeah, that's about it. That's what I want to tell about team growth. Any questions about this slide? No questions. That's amazing. And then code that. So instead of like explanation, I want you guys to see this GIF. If you are not careful, this code that panda will come at your work desk and do this thing. Do you guys know what code that is? Who doesn't know? No, no, no. You know what code that is? No. What about you? You look like you know. Nice. So code that, if you cut on building a good code and you, for example, said, okay, let's do it really fast, but let's just finish this feature, right? Because we need to finish like tomorrow, right? And if you keep doing that without organizing your code well, at some point, all these things you cut off in the beginning will fire back, and then you have a lot of bugs, you have a lot of complexity, and it will actually take longer to fix those issues than if you designed it well from the beginning, and if you like basically did it in a proper way. Of course, it's not possible each time to like commit like an ideal code, but at least you want to design it in a good way. You want to test it. You want to have like a minimum amount of tests, and you want to keep the design in mind. So the code that panda won't come to you and crash your desktop. It was a desktop, I guess. Any questions about code that? No. Okay. Cool. And the next slide is very important. Thank you for your attention, and feel free to come to ask any questions about scaling or not scaling. You have any questions?
Question guy.
Yes, yes, please. Thanks for coming. Now I need to invite you to all my talks, all my meetups.
No, it's related to two slides. One is about run tests, and the other one was like dependencies, right? So like writing unit tests.
Timelines.
Yeah, Facebook actually is very notorious for changing the API and breaking everything, and I agree you should not use Facebook API because when I worked with Facebook API, it was a disaster. They just change everything, and they're big, they don't care, right? But true good APIs are some APIs when you, as you said, when you release a version of API, they will never change it. Never change it. They will suffer. That will like. If they have users, they will never change the version of API. And when they want to introduce a break and change, they introduce it in a new version of the API, right? But then still, how do you test those? To test external API, you mock them, right? So you make like fake sort of API routes, and then
Ones are the problematic ones.
Facebook, they don't care much. They when I was using them, they would change the API like 50 times, and we were so angry. All the engineers were so angry. It was like, yeah, it was a hell.
It has cost us a lot of money.
can mitigate a bit if you try using open source libraries, because they will update.
And I was just looking at, you have tools, we have experience using some recording tool that pulls in some of the data from production and it can replay it in a dev or staging environment. Things like that.
If you're using Rails, there's a gem called VCR, for example. Exactly does that. The first time that your test run, it's going to do a real request to Facebook and record the results. And the next time you run the test, it's just going to reuse the responsive recorded. Which means that when Facebook changes your API, you're not going to know it because you're not doing a request to Facebook every time.
Yeah, it's in fact I also use this gem and it was pretty handy. And with Facebook, you have to, to do it manually sometimes to make sure they didn't change. Moreover, they also changed the API. Didn't tell us that they changed the API. Yeah, so I guess you have to guess. Maybe because they don't run tests.
How Salesforce API?
Oh, it's also tested. They test everything so well.
Mostly enterprise.
Yeah, it's super secure, super tested, and they probably for a small feature they have so many tests, way more than the whole Facebook has. It's probably not true, but it's a good exaggeration. Yeah, all enterprise. I think all enterprise grade softwares that work with enterprise, they have to test a lot everything. Yes, you had a question?
Yeah, you just mentioned on your slides you mentioned the unit testing and then integration testing. Could you briefly touch on for Salesforce what kind of the more nuanced testing that you would do? Things like multi-testing, end-to-end testing.
Oh, they have so many layers of tests. I didn't cover it here, but there is also a thing called performance tests, right? And there's also many levels of them. There's performance tests for the front end. There's performance tests for the back end. And they use different frameworks. They use different benchmarks. And they work a little differently. So they have, for example, for the front end test, is pretty, it's sort of complicated because it can run just differently each time. So there's an average. And you see if the result deviates from the average and see if there's regression. But also there's unit tests, integration tests. Integration tests usually are slower, but they're a very important part. Unit tests and performance tests. And there's many different unit tests for different sub-apps for different parts of the infrastructure. And there's threshold, so the test coverage should be more than 80%. Well, I think it's one of the good practices, right, to have a threshold. But also, it's very convenient to. It's very good to have a performance tests in place as well, especially from the front end if you build some. If you have a lot of front end logic, because you can introduce regressions on newer versions, or new components can regress the whole app. Yeah. So without tests, there's no mature company that has a small test coverage. I think. So write tests. Order T-shirts. It's called I write tests.
I am a test case.
Yeah. I'm a test ninja. And if you're not engineers yet, but you'll be engineers soon. So you said you're not engineers, right? But you are planning to be engineers soon? Or you do? Yeah. So remember that the test it's fun to write. When you learn how to write them, it's very fun. And it's also very fun to tell other engineers who don't write tests the test report. In the most passive-aggressive way ever possible. Yeah. Involving using different emojis. Yeah. You have any other questions?
No.
Are you a bit familiar with Heroku?
Yes, at some
And
extent.
maybe how their auto-scaling works? Because I have a question specific to maybe how that works.
So you have a question specific to autoscaling that Heroku introduces a new feature, like Heroku native autoscaling?
Yes, maybe. I don't know. Maybe it's a stupid question. So let's say I have an app. It's a Node.js app. Maybe not Node.js. Maybe Ruby. It's deployed to an Heroku.
Maybe in English.
Maybe in English. It's deployed to Heroku, and I noticed that during certain times it uses more resources than I have available in one dyno.
Yep.
Would just turning on dyno autoscaling solve those issues, or would I have to do specific things on my app to support that automatic scaling?
Yep, I have an answer, I think, for you. So they introduced an autoscaling feature, like native autoscaling feature, that I haven't looked at, but you want to explore it. But what we did before they had autoscaling feature, right? So we mostly scaled for the backend for the jobs, right? And then we would have another API that would see how many jobs are active right now in the queue. And if this amount would be like more than X, that would launch more instances, right? Depending on how big the queue is. If it's like 3 times more than X, it would launch 3 times more instances. Because it's very easy to launch more instances, scale Heroku. It's just like one from a command line on your server, right? On Amazon or even your local machine, you can scale them up and down. And that we see the statistics on the jobs in the queue and then scale based on that. But if you want to scale a web sort of application, right, just web requests part, I think now their auto scaling feature is mature enough to use, although I haven't played with it.
Thanks.
Yeah. But those auto scaling, a lot of companies actually solved it in a different way. And one of my coworkers recently introduced a new solution that I haven't looked at yet, but maybe I'll ask her how she did it and tell you. Thanks for the question. Yes, more questions. But by the way, I want to tell you guys, until every one of you asks at least 3 questions each, we will have to stay here. Okay?
I have a question about unit tests. What is good test for you? How do you define good tests?
Oh, that's a very good and philosophical question. For what is a good test? A good test is, I probably won't come up with a good definition right at the spot, but a good test is a test that tests something useful. So for example, if you test something that's being hard-coded, that's a bad test, because if some data changes, it won't be able to test the change, the difference, right? So you wanna make sure that you test the right, so-called the right thing. So for example, unit tests is usually you test different functions, right? So for example, function that returns some data based on input data, and you go through a few cases, right? You feed it with like two different types of data, and you know that the result is supposed to be something, right? And you say, okay, after completion of this function, result should be like this. So for example, if based on the, like let's say you have a function based on the ingredients, it will give you the brand of the tea, right? So the function is get the tea brand, right? And you run 2 tests saying like, okay, first it's green and sour. Then it will be Itoan, right? And then you make sure that the result of the test will return Itoan, right? And then it's black and sweet, and then the result will be any American brand of tea, right? Oh, and it's also and unhealthy, yeah. And you wanna make sure that the result should be something that you hard-coded and test, but that should be a computational result of the function you're testing. So unit tests are usually used to test like some like smaller parts of code, right? But integration tests are tests to test either the whole infrastructure or like some bigger part of code where there are different functions communicate with each other, right? So a holistic test, so-called holistic tests, integration tests. So you want to make sure that it's probably a lot of companies that I see right now, they write a lot of small tests, a lot of unit tests, because it's faster to write, they're faster to sort of launch, and then they write a little less integration tests, but they're also important to make sure that different parts communicate well. Did I miss anything? Maybe you can add to that. Yes.
I would add that your test needs to be readable. What happens with my team is that somebody writes a test and it's like, what was this test for? And sometimes it's not immediately apparent.
Because also it's very important. So tests also describe the feature, right? So if you wanna, if I need to maintain some feature, I go to the test and see how it works, and I understand. So this API works this way, but basically seeing an example. And if I see some really complicated test that developers can understand like easily, that means you probably want to rewrite it in simplify them so they're easy to read. And I think that's very big and very important for tests to be readable. Thanks.
So I just want to ask, how you test the private method?
How to test private method? There are different approaches to those. So there's probably a public function that uses this private method that you want to test.
I want to test the private method directly.
Just the private method?
Yeah.
Why do
So
you need to test it first?
I just, how to say, from experience, I want to ask, so do you test the private method or you test through the public method?
yeah, so usually don't, but also you want to build application also in a way that is testable. So you don't want to build a lot of like private methods that they're completely untestable. But if you really wanted to like test the private method, if you like really wanted to test the private method, you probably can just test private method. There's probably a way. In a lot of languages, it's possible to test private method. But it's better to design your app in a way you can test it, and probably you can introduce like a few public methods, right? So your private method can be tested through a public method.
The question with why was usually you put something private that's not going to get out of this, for example, this class context. So it's not something that you're exposing to other users, other developers. So we don't really care if it changes as long as your public API is still working the way you designed it.
Yeah, I want to add that what you said, since you're talking about private method, talking about testing a class, and you don't want to test how it achieves what you want it to achieve. You don't want to test those implementation details, we call them. So yeah, I would also just say don't test them, just test the public interface and what it's supposed to be doing.
Yeah, because if your class has only private methods and has no public methods, it's something is wrong.
How to say, one public method, they have, how to say, several private methods, and I want to test, how to say, to assure that how to say, the private method is correct and the public method is correct. So how about that case?
Yeah, so it makes the question make sense in a way that so you want there might be private methods that you might want to test too, sort of thing, but you want to like maybe alter the architecture a little bit so they are more accessible to testing. For example, if there's only one public method, like compute, right? And then there's like 50 private methods that it uses. And you probably want to like divide this compute to like compute first part, compute second part, compute third part. So to basically break down so it's easier to test the class. Yes, please.
When you're working on a small application and you're the only sole developer building it, how important do you consider tests to be created in this scenario?
Tests?
Yeah.
That's also a very good question. So it also depends on your goals. If your presentation is tomorrow to the investors, and if you don't care if it breaks a little bit, and then you know that after tomorrow you will have funding and you can write tests, then it's more about like it can be more business decision, right? But if you want to have like high standards as a software engineer, and if you also care enough to break, it will slow you down writing tests, right? So if you know that it's not about the presentation, it's not about like just demo, it's about like your customers, right? Then you want to write tests well. Because at the presentation, if it breaks a little bit, it's fine. There's no like customers information. You just want to show them what your app can do. But if you run it in production, and if you have engineering team, users, then and also for self-discipline, right? It's nicer to have like develop a good habit of writing like beautiful code to have tests in place. But sometimes if you like extreme sports, like rising on like climbing on tall buildings, you know, and something dangerous, you can also skip the test and see where it brings you. Maybe get some adrenaline. Yeah. Any more questions? Awesome, you've been a very good audience. Not many questions, and thank you so much for coming. Thanks to Chrysalis for having me. And now you can stay and hang out a little bit, or you are free to go and start writing tests.